Here we're looking at Doppler effect. The Doppler effect, and if you read the orange box up here, it basically gives you a shift in the pitch. For sound especially, this is dealing with electromagnetic waves, but generally where you would see, there are obviously cases where you have like a red shift in light, but for the Doppler effect in sound, like it's the case where you hear a police siren. As the police car moves towards you, you actually hear a higher pitch than what's being emitted. As it moves away from you, you hear a lower pitch than what's being emitted. It is not to be confused with the actual volume, right? The volume is dictated more by the distance, but the Doppler effect, the change in frequency, is affected by the relative motion of the observer and the source. And in this equation, f prime is the new frequency, with the one that would be coming back from the speeding car. Fs is the source. The V is, in this case, you would be using the speed of electromagnetic waves was 3 times 10 to the 8th meters per second. V of the observer, right, since we're moving away from the source, you'd be using negative 24 meters per second. And Vs, you'd be using 42 meters per second, right? And if you ever get confused with signs, consider the case of like one of them being 0, right? Like if the police car were stationary and the speeder is moving towards you, you would expect the denominator to get smaller so that the overall frequency goes up. And that's how I decide on the signs here. But generally, if they're moving closer together, the plus on top and the minus on the bottom works. If they're moving further apart, then there would be plus on the bottom and minus on top. And when we plug all this in, we would get f prime equals 6 times 10 to the 9th, right? That's your original frequency. 3 times 10 to the 8th minus 24, and then 3 times 10 to the 8th minus 42. And even though the scale of these numbers seems really big, right, as you multiply it by 6 times 10 to the 9th, you do end up with 6 0 0 0 0 0 3 6 0 hertz. That's 1 2 3 4 5 6 7 8. Whoops, there should be another 0 in here. 1 2 3 4 5 6 7 8 9. And so when you calculate the change in frequency, you'd be doing f prime minus fs, the source, and you would end up with a change of 360 hertz. Okay, so to recap, I think the biggest thing is the plus on top and the minus on the bottom. This goes for the source and the observer getting closer. Right. And I think that's really the one case that you really want to remember well, because if you try to remember all 4 variations on that, it's really confusing. But if you just remember the plus on top and minus on the bottom is the source and the observer getting closer together, then you can kind of figure out the signs based off of that.